Hi guys, welcome back to my channel. This is Engineer's Guide. Let's talk about the fire pump set today, and the system that we are going to use. The controllers is actually the maker. Controller is Kata Factory, that's previously NAFFCO. So this is actually the controller that we are using, Kata Factory, right? So it also consists of the jockey pump, the electric, all right, then the diesel pump. So these are actually mainly the required pumps that are being needed in a fire pump room. We always have to have the jockey pump, the electric pump, and the diesel pump. Now, looking on to this, these are actually the controllers. So the pumps are going to be here. This is an engine, a diesel run engine, and on the far, this is the jockey pump, and this side is the electric operated fire pump, and with this side also is actually the diesel tank. So the diesel tank, you could see from here that the pipes are being connected from here down through this drain. It's actually not a drain, but it was purposely made for this, so it will be hidden. Most of the pump rooms you will go, you will see these lines exposed. Now, exposing it makes it difficult to just maneuver inside the fire pump room, of which it can cause a trip, or somebody can fall also as well. So make sure that mostly all the things, the possible ways that you can make it hidden, it's for the better, so there will be space. So from here you could see that there are spaces here, and this pipe that you are looking at was purposely made before for the cabling. But looking at this pump, you could see that this pump, the connection part is at the opposite side, all right? So a cable tray has to be incorporated. Now, with the cable tray, since the panels are down, the controllers are down, many would have suggested that we should put the cable tray down, of which most of the people are doing. All right, they would tell you that we will fix it on the ground after we put cover, which also is allowed, but it's supposed to be of a clearance, like a 12-centimeter clearance. So you could see from here, it's almost like that. There is this clearance. It's supposed to be of a little bit height. Then it has to be covered also as well. But for here, what we did here was the cable tray was mounted to the top, okay? So from here, this is how the channel is being fixed. Then on the channel between it is the cable tray on which the cables are going. So it was fixed from the roof directly to the ground to give it a solidified support, all right? Then the cable tray is running through, and on the cable tray also we have threaded rods with channels that is being made, okay? So it will run through. Then from there we're going to have the 90 degrees elbow, okay? Then we will have the bend, then it will just come down, then to this elbow also as well. Then this will be distributed evenly under the controller. So diesel will get its cables, the jockey will also get its cable, and the electric also as well. So when you look, there is still ongoing work here, so there will be certain things that you see around. It's just an ongoing site, all right? It has still not been commissioned yet, but I would like to share with you, and so we can observe the things that are around on a new site, okay? So from this, you could see that even there is a separate isolation switch, or this is from the LV panel to the fire pump for the electric. So basically the electric has to have its own isolation switch from the power supply. So you can see the cable directly coming to, so let's see what is inside. All right, so it came directly from here, then on to the isolation switch RYB. I believe there was a phase reversal, that's why they changed the phase here. All right, mostly this is what we are known for, RYB, and I believe this is what mostly we all say. Okay, so this is actually the relay board, and this board here is the display board. We have contactors in here. This is like three-phase star delta system, so it's going to run on star delta. So it will be first run on the star, and after a few seconds it's going to change to delta, then it will run continuously until it being stopped. So this is actually the controller itself, right? There is power supply, so you can always see this green light on the surge arrestor, which is really important. All right, now it's still ongoing, but you can see that the wiring from the motor has also been connected to the delta and the main contactor. All right, so you could see also from here we have the cables connected, RYB, but you can see that the phase has been changed. Why? Because it's of the rotation. When the rotation changes, you either change it in the controller or you change it on in the controller itself. All right, so looking at this, you could see that jockey is also three-phase. All right, so it also has its isolation switch, which is connected directly to this. All right, we have video on the jockey already on our page, so you could just observe and check on that. And the cable here is coming directly from the jockey pump. Okay, so this is actually also the diesel. Now there is this smart charging system that NAFFCO or Qatar factory has incorporated in their systems. This system is already off. All right, it's already off. They are still working on some of the supplies, and the batteries, the fuel line has still not yet been connected. That's why we are not putting on this one to just run, but for you to just observe. This is actually the display board, and this is the relay board, the motherboard. Then we have the breakers, we have the CRs, the control relays. All right, basically especially the CR21. Those that know, the CR21 is the run relay, of which when it runs, anything that you can give it will just be used as you can get the signal from there. And this actually, what we are using here is a 12 volts panel with 2 batteries with 2 chargers. All right, so it's quite nice. So these are the chargers that will be charging the batteries, and the cables has been connected here directly, which has its own drawings also as well. Okay, on how it's supposed to be done, and everything has been terminated very well. So every fire pump room has to have sprinkler boxes, and the purpose of the sprinkler box to have spare sprinklers, so then in case of any emergency you could just get some from here to just fix there on site. So you're supposed to have different kinds. The ones that has been installed, all kinds, it's types you're supposed to have. If you installed sidewall, you installed pendant, you installed upright, you concealed, the concealed type. Okay, all you need to keep spare inside the sprinkler box in the fire pump rooms. And at a point also you need to include Teflon tapes, because there is this key also here that you can use. The key is actually used to install, or we call it the wrench or the spanner. That is for the sprinklers, all right? So it's really important. So then in case of any emergency, you come to the fire pump room, then you can get, and every fire pump room has to be visually clear. It's supposed to have clarity with emergency light. With here, we have heat detectors also here. And we have sprinklers also here as well. So the sprinklers are not, the pumps are not only protecting outside, they are protecting themselves also as well. It's amazing, right? And every pump has to have a fan. It has to have a supply, an AC or a fresh air supply, and we're supposed to have an exhaust also as well. So there will always be air circulation, so the pump room wouldn't be so much suffocating whenever that you are working in here. So quickly, let's go on to the network. So this fire pump, actually, we're going to look at something here. So as we said of the cable tray, so you saw how it went, okay? The same thing with the diesel also. It was mounted with a support, with a channel, okay? Then this cable tray goes directly here up onto the jockey, and this is for the electric. So the wiring and the termination is going to be done. This is actually the engine, I believe. The makers is Kirloskar, right? So you can see from here, Kirloskar. It's an Indian brand, yeah. So actually the performance is, yeah, Kirloskar. All right. So you could see from here, this is actually, this pump is what we call the centrifugal end suction pump, all right? So you could see that it's sucking from this side, the end side, and it's going up, all right? So this is actually the suction part. This is the suction header, okay? And that is the level, water level indicator showing there. So we have 2 tanks, and the capacity of the water tank is actually 30,000 gallons, all right? So how then do we supply water to the water tank, and how will we know that there is water in the tank, all right? So the supply is going to come from the water, direct water supply from our systems. So you could see these green PPR pipes, okay? The supply is coming from here, directly going to the tanks. And with the tanks, there is a float valve that is inside, okay, which is holding the water, which is, if the water goes down, then the float valve will just give way for water to pass. After it is full to the maximum, it will just close automatically by itself, all right? So then to maintain the level of water inside. But in case it fails, we have something we call the overflow, which is here. So there is this overflow one directed to the drain, and another overflow number 2 directed also to the drain. And in every pump room, there is this circulation valve, which is always open. I will get there, so you can just look at it. Okay, so this is the circulation line which connects both tanks together, all right? So it can just keep the water level on the same level. So you could see from here, the level of the water is 100%, okay? And that one also is just 100, also same, the last part, okay? So we have a suction valve directly from the tank. Then the second one is also here, also from the tank. Then we're going to have a suction header of which the distribution is going to be done. So the jockey's own is being tapped here on a 2-inch with a 2-inch valve, okay? No, this is actually 2.5, all right? So it's 2.5, yes. It's 2.5. So then here it's being reduced then to to the pump itself, then also another reducer to a 2.5 inch. Then we have this check valve. On the check valve, between the check valve and the valve, we have the sensing line. The sensing line is the one that is the pressure that is in the system is being translated digitally on the system through a pressure transducer. All right, so we will have a pressure switch or a pressure transducer that is being installed in the system, of which the sensing line is always connected to. And every suction, every sensing line is supposed to have at least 2 check valves on it, which is going in the opposite direction. As per standards, it's supposed to be in an opposite, because mostly you just check on the flow and you let it go through the flow. But this time around, it's supposed to be in an opposite direction. And there has to be a 4mm hole that is being drilled in. So it means the water that is going to go wouldn't have that much pressure. It will just go steady, right? I believe they will be asking, people will be asking, why is it supposed to be so? Okay, for now, let's take it, it's a standard, all right? We just take it, you can just make a research and just comment why. We need to just put the, because when you look at the sense, you look at the check valve, the NRV, you could see the direction is upward. And the other one is coming, you see this one is going up, okay? The supply is coming from that side. So it's supposed to go down, right? But this is going in the opposite direction. But there is a hole that has been drilled in, all right? So you can just check more on that. And you can see this side also. It's also the same, all right? So all the system has sensing line and going in the opposite direction. And there is a 4mm hole that has been drilled in the check valve. Okay, so this is it for the jockey, and that is it also for the diesel. And this also is connected directly to the diesel. So you could see that everything that we are doing here has been made on a level of height. Okay, so then there will not be any distraction. Most of the sites you will see the sensing lines on the floor, and because it's copper, people tend to step on it and it starts to get broken. There will be sometimes leakages. When it breaks, you can see that most of the part of this is welded. Okay, we call it soldering. It has been soldered. All right. So with this, if it breaks, you need to solder it again. All right. It wouldn't be like the ones that has. Also, there's an option. You could just put the fittings and just do by Teflon tape and tightening and doing all sort of things to just keep it right. So I believe that this helps, all right? And looking at this from this side, this is the last part of the suction, and you could see that this is the main electric suction valve, okay? This is the main suction valve, but this is for electric. This is specific. It's for the electric because it's going directly to the electric, all right? So we have one pressure gauge here, which is a compound pressure gauge, and we have the next is another one also here, okay? So, and you could see the direction of the pump, how it's going to rotate to just pump the water, okay? So water is going to be sucked from here, and this meter here, let's face it, so you could see the pressure is not on 0, it's more than 0, okay? And we have 1 here, so by calculating it in PSI, you could say you are around like, so let's count, 20, 10, 8, 6, 4, so around like +2 PSI like this, okay? So this is the pump not running, it's just flowing. So basically our actual the design for the suction, when we are recording, we used to just put just +2 +2 +2 on a normal basis. Okay, the water running on a gravitational on gravity, this is what is going into the pump. That's why it's better to elevate. The suction is supposed to be a little bit bigger, but here you can find that it's all 6 inch. I believe the elevation is good, so then water can just go directly into the pump. Okay, so from here you could see that the pump that we're using is how many GPM. What is the GPM of the pump? So you can tell me from there. It's 500 GPM. All right, so if 500 GPM, then it means to say our flow meter is going to be 1000 GPM. That we talked about this also before. All right, so from this side you will see the discharge pressure gauge, also measuring in bar and PSI, whichever way that you want it. Then from this end you will come to the check valve, and the check valve, there is where the connection of the sensing line is also connected to the discharge valve of the electric, then to the main discharge header. All right, so the diesel also is just the same. So you could see the main discharge header is having an air release valve, and it's also having a pressure gauge. All right, it is important because this is an end suction pump. It's not like the horizontal split case that you can put the air release on top of it, right? So to eliminate the air, the presence of air that is in, that is why we are putting the air release there, to just any air that is trapped in the lines can be just released by the air release. All right, okay, so going on now, you could see that this is the main discharge header, this is the discharge line, and it flows through main discharge line directly through to this discharge line, and from this pipe it comes directly to the alarm check valve. So this is the system line, and this is the main discharge valve. So in case of any testing, this is the valve that we actually going to connect, and you could see that it's being connected with temper switches. All the valves that I showed you were connected, and the temper switch is also connected to a module which is going to the fire alarm panel. All right, so then if somebody will tamper with this valve, an indication is going to be given to the fire alarm panel. All right, so basically all the valves that we have here has been wired. So you could see this one is here going. This butterfly valve has its own, and these are the models that have lined up here. All has been connected. I believe it makes the work easier, and it makes it efficient whenever that you are working on. Okay, or if somebody tampers with anything, it will be easy. So during testing, if you would want to test flow test, what you have to do is to close the main discharge valve. All right, so if water will come from here, and it will come up to this side, and it will meet this valve closed, then the water will definitely have its priority passing through the test line. Okay, so this is the throttle, the bypass valve, and the throttle valve. Okay, all has to be in normally closed condition. So as per whether this valve, the suction valves, all has to be normally open. So as per the normally open, as per its condition, is how you're going to use to just wire the temper switch, either NO or NC. Okay, so the bypass and the throttle valve, and that's the flow meter. The flow meter is 1000 GPM, US GPM. Okay, so during testing, we did the testing before, right? During testing, you can open the bypass valve and you use the throttle valve to guide you through the GPM. It's either the 0%, the 100%, and the 150%, which is the major one that is being looked at anytime that we are doing testing. All right. So why is it necessary for us to have a level indicator? This is a question and I would like you to just answer in the comment section. And it is said that we're supposed to have 10D. Okay, why do we have to have 10D in the pipeline? And we're looking at this, do we meet the requirements of the 10D? Please answer us on the comment section. And from this side, you could see when you check in test line, we're supposed to have the 5D and the 2D. So looking at this, where the valves are being positioned, is it correct? So you can also leave your answers in the comment section. And why is the need for us to have sprinklers in the fire pump room? And we also have smoke heat detectors also as well in the fire pump room. Why is it necessary for us to have these things? Which kind of requirements is that? I would like you to just contribute. Okay, so you could see the exhaust manifold has been cladded with a heat resistant material going all the way outside. Okay, this is actually good. It limits the heat that will be generated and be deposited inside the room, because people will be inside to do the testing, right? So it's really necessary to just do the cladding, and it's also a requirement that has to be done. And the water tank itself, so as we talked about, it has an opening that you can just observe visually. And here, this is the second one. This is the level indicator: 0, 25, 50, 75, and 100. So you could see it in the 100%. Okay, and we have a drain. This drain is in case you would want to clean, or there's something that you need to do inside the tank, because it's concrete. And regardless, even if it's concrete or not, and you want to clean, you need to drain. Unless you can dive, then he will do that. All right, so just stay tuned. Anytime that we will do the testing, I will just take the video and I will just share with you guys also as well. All right, this is the 12 volts batteries, 2 pieces. Okay, so if you have any comments, any suggestions, and as you can see from here, there is this MCC for the fire pump room. Okay, this is the fresh air fan and the exhaust fan. After, when it's being started, we're going to put all in auto, and when the diesel run, most especially, we put it in engine run, so the exhaust will start to run, so then to remove any heat deposited in the room. So you could see that there are control modules that are being connected there, that when the pump runs, when there's fire in the basement, it will give a signal for it to run. A whole lot, that is another space altogether in the ventilation system. And this is actually the diesel tank. There will be, it's 150 gallons, okay? And it always comes with the filling line. And this is actually the filling line. This is an air vent. And what we see here is the exhaust also as well, okay? The exhaust line. So this 2-inch is the filling line that is deposited, and this is the level indicator. This is the air vent, and that is the exhaust, okay? Exhaust. So this is Engineer's Guide. Thanks for watching. Please like, share, comment, and subscribe to our channel. Thanks very much. Bye-bye.